Welcome to the video for Unit 7, Day 8, Exponential Modeling. This is the video in which we'll talk about some real-world applications, which means you'll be solving word problems. We will be using the same basic formula that you're used to from doing graphs and tables, but this time we'll be giving some meaning to those variables. Take a moment to make sure that you're familiar with this formula and to write down any notes that you might need later. As you'll notice, f of x represents the end amount. So basically, we're going to be telling a story. And each of these word problems represents a story where you start with something, and then there's a change to it that happens at a certain rate. And then you wait a certain amount of time, and you end up with something different than what you started with. The four pieces of this equation represent the four elements of that story. If you can read and understand the story, the equation will not be a problem. However, if you read and only try to pick out numbers, you will likely run into trouble. The steps that we use for word problems are always the same, so I don't think I need to talk about them. Let's look at the first example. In this example, we're talking about termites. It reads, the population of termites in a tree triples each day. If the population started with 10 termites, how many are there after a week? If you're someone who historically has not enjoyed word problems, I can recommend that you cross out unimportant information and circle important information, and that you pause at the end of each sentence to think about what might be important or unimportant. Here's what I identified. First of all, in the first sentence, the only word that seemed to matter to me was the word triples. I know that triples means times 3, and if I think back to the equation that I'm going to be using, I remember that part of the story is about something changing. Triples in this case is telling me about how the termites change. So I have a pretty good hint that that 3 is going to represent the R value, because that's the change factor. We also call it the multiplier. As I continue reading, if the population started with 10 termites, I'm going to cross these extra words out and just stick with the 10 termites, which I just identified to be the starting amount. Finally, the question is asking me about how many there are, which means I'm trying to find the total at the end, which is represented by f of x. And a week is a little tricky here because I know that's talking about time, but the change is actually happening day by day. So instead of 1 week, I'm going to record the time as being 7 days. From here, you can put things together using the formula. Pause if you need to go back and find it again. And to figure out what f of x is, all I need to do is simplify the right-hand side. Make sure that you follow order of operations, doing the exponent before you multiply. When you set up your work for word problems, I expect that your free response answers have these 4 elements. The given information is identified, you tell me what you're looking for, you show me the math, and then your answer is in a sentence form, just like mine. Let's look at a second example that'll be one step more complicated. In this problem, we're talking about chemicals, and this is something you would actually really commonly encounter in a chemistry class or later in an archaeology class where you're trying to figure out the amount of time that some chemical is decaying. A chemical compound is decaying in a chemical reaction. Each hour, there is half the amount there was before. Out of everything I've read, so far the important word, and the only important word that I've noticed, is 1/2. Furthermore, I recognize that that's how it's changing. So I'm going to go ahead and annotate that. Once again, each hour there is half the amount there was before. If you had 80 grams at 6 a.m., at what time will there only be 5 grams left? This is a little tricky because I don't see a starting amount, but if you read it again to yourself, if you had 80 grams at 6 a.m., at what time will there be only 5 grams left? You'll realize that 6 a.m. must be the time at which they start. And the important thing to notice is that that's not an amount of time that goes by. That's just the starting point. So 6 a.m. does not represent T, but it does represent the beginning of this story, which represents 80 grams to be A, which is your initial value. Putting these details together, here are the given information that I came up with. Half is the change factor R. 80 is the starting amount A. 5 grams left, that's how much there'll be at the end. So that's f of x, which means we're looking for time. This might be a little confusing at first because it seems like they tell us the time, so you need to go back to the meaning of the story. In our story, in our equation, the t for time is an amount of time that passes, not a starting time or an ending time. The difference in this equation comes after you identify your givens and do your setup. And the major difference is that in this case we are looking for the exponent. And this is where you have to draw on your exponential knowledge. It's not just about simplifying now, it's about solving. In order to get this exponent by itself, bells should go off in your head because you know to find an exponent, we use a logarithm. First step is just to isolate the base. So go ahead and divide 80. You can do that as a fraction and simplify it to 1 over 116, or you can do it by turning it into a decimal. From here, I convert that into log form. The base comes down, the answer is the argument, and t, the exponent, is what it equals on the other side. Now, this turns out to be a logarithm that I can do in my head. The question it's asking is log base 1/2 to what power equals 1 over 16. And the truth is I can multiply 1/2 times itself 4 times to get 1 over 16, which makes the answer 4. If that's not something you're comfortable doing in your head, you could also find this answer by using the decimal values and by turning it into your calculator using the fraction form. Finally, 4 hours isn't really my answer because the question was asking at what time. If we started at 6 a.m., 4 hours later would be 10 a.m. Let's look at some for you. Here's the first example. Pause the video as you work it out, and then I'll show you the answers. Here's the answer for the first practice problem. Here's the second practice problem. Pause the video as you work it out. When you press play, I'll show you the answer. Here's the answer to the second practice problem. Here's the third practice problem. And the answer to the third problem looks like this. We'll do 2 more. This is number 4. And this is what the work looks like for number 4. And this is number 5. Followed by the work for number 5. In the next video, we'll continue talking about percents using a lot of the same techniques, but pause now to make sure that you have the basic formula solid first.